So, hello everyone. Nice to meet you. I don't know if you've got an email from me. I guess if you looked at your mailbox yesterday evening, you probably saw my name. So my name is Inbal Levi. Welcome to Core CPP. I am one of the organizers of this conference, which is running for the 5th year. Actually, on the middle, we had a small gap because of pandemic. But this is started in 2019, and back in 2019, I was just a speaker. Then I've joined the organizing team, and we run in this conference, and I think you can see the level of details and quality of our talks. I think this conference, by no means, is an international level conference, and I'm very, very proud that we got here. And I really appreciate everyone for joining us, and I hope you'll enjoy the conference. So first of all, thank you everyone for coming today, and thank you for all my co-organizers and everyone that's been working so hard to get this conference to where it is. All right, we have our safe space team right here, and they're awesome. Go and talk to them if you want to let them know about anything. They are very friendly and personally close friends of mine as well, and all of them are very welcoming and nice. So let's start. So today I'm going to talk about reflection. So I don't know if you heard, C++26, we're gonna have reflection. There's very likely that we're gonna have reflection in C++. And I hope you, for the very least, heard about this. There were a few trip reports published on the Poland meeting, which is the latest ISO meeting, and already been mentioned in this. I will say that things are not final until they are final and in the draft. But we are very, very likely in this proposal in very, very advanced stage. So who am I and why do I talk to you about reflection today? So first of all, I'm a lead C++ developer. I'm also an ISO Foundation and Boost Foundation board member and an active member of the ISO committee. So also Israeli National Body Chair. So regarding reflection specifically, the way the committee works, we review proposals in 2 different tracks. One of them is basically for language targeting proposals, and the other one is for library targeting proposals. Now, funny enough, reflection aims for both of those because reflection have both the language extensions and also a bunch of standard library functions that belongs into the stud meta namespace. So in order for reflection to get to the final stage, it needed to be reviewed both in language and in library evolution group. And we've just forwarded in Poland, which was last week, the last bits of reflection from the standard library. So this is basically being reviewed in our working groups, and as I said, targeting 26. Very exciting. So what is reflection? When I say reflection, what do I actually mean? So reflection is the ability of a software to observe its own code, its own text, right? And when we talk about reflection in the context of C++, I specifically refer to static reflection. There's also, maybe you've seen from Python, for example, maybe from Java, there's also options for, I'd say in Python, you can observe using the interpreter in a way, write the structures of the language. But this is pretty novel in a sense, because no other language has such a powerful reflection infrastructure in compile time. So again, consider the fact that this is static reflection. What we talk about here, whenever I mention reflection, I mean static reflection. And the intention of static reflection is the compiler, right? You could basically, the compiler is the tool that runs and look at your code and basically generates or observe your program, not the interpreter or like, for example, in Java, could be, I'm assuming JVM. And it may be possible to also carry this information to runtime. So technically, right, in C++, we compile, we get a binary. It's technically possible to leave this information, and then you could hypothetically get some information in runtime. However, this is not what I'm talking about here. This has never been, this has been, let's say, voted down in earlier stage because the complexity, because of the binary size, because of other constraints that we care about in C++. So again, what I'm talking about here is static reflection. Disclaimer, I'm not saying that we're not going to have anything possibly in the future, but that's not the proposal on the table at this point. So what are we going to do during this hour, or a bit less that I have now? We're going to start with intro to reflection. We're going to go over all the history of how did we got here briefly, and then the latest proposal that I've been referring to, that's P2996, which is the reflection proposal targeting 26. And we're going to see some usage examples. There have been a few very, very nice talks in CPP Now and in CPPCon this year. If you want to search for them, they present, one is by Sakshan, one is by David, which is the original, one of the authors of the proposal itself. And they all present a very interesting use cases and usage. So feel free to search for that. But here we're going to see some basic use cases so that you can follow up on the other talks. And on the second part, we're going to talk about the impact on our code bases, right? So again, I've talked about, we're basically introducing a new tool. So keep that in mind when we talk about reflection. This is going to impact also our CI, the way we build code, the way we have code bases, and the way we manage them, and the impact on our code. So let's start. Any questions so far, by the way? Everyone are up? It is a bit early in the morning. Yes. What's your name? Sorry. Moti? Yeah.
In the last C++ talk, you heard about contracts and that nobody understands them. So reflection is the way to simplify them?
No. So in the core C++ last year? Yes. So Moti asking if reflection is a way to simplify contracts because he heard last year we were talking about contracts. So no, those are parallel features. Contracts is also targeting 26. Contract is going to have its own separate syntax. Again, everything I say here as targeting 26, you need to keep in mind that it's not final yet. So as long as it haven't been voted into the draft, we don't know that it's going to be in the version as guaranteed. But both features targeting 26. Contracts is focusing on a bit of a different thing. I would say it's an extension for asserts that you know, as you know them today, but it is a separate feature. So reflection is basically the ability to reflect on your code, to basically query the code. Let's say I write a class, and you're going to see an example soon, and I want to find out what's the members of this class. Contracts are a bit of a different thing. They are basically a way for us to define precondition and postconditions on our functions and behave accordingly. So two parallel features, not necessarily related. But thank you for the question. All right, so let's start with a brief history. So first time, at least that I could find, that reflection was mentioned in the discussion in the standard is 2006. That was by Matusz Korczyk, sorry, I hope I say his name correctly. And he had a mirror reflection library. So basically, the need for observing your structures and your code have came up long time ago, and I think this really signifies the significance of this proposal. But the way we did this before, or at least in the early version of discussing this feature, was by libraries. So template metaprogramming. You can also see this paper. By the way, Mike Spartus gave a talk in our conference last year. He gave a very interesting talk about API with cloud, and I actually met him not long ago. I hope he'll be back for next year. So yeah, he already tried to basically put like the framework of what can we do with reflection. And as I said, Matush was also dealing with basically proposing things that were basically based on things you know today as type traits. So right, we have type traits in the standard library, and we can query our types to get some information. So that would be a very early form of reflection in a sense. But this is relying on template metaprogramming. By the way, some of the traits are compiler, that have compiler support. It's called like compiler magic behind the scenes. So not all the traits are pure library extensions. But what you know today as traits was what was discussed. Then we had Boost HANA, which was the first attempt for actual full-blown, I'd say, template metaprogramming library trying to reflect your code base. So basically, written by Louis Dion, also based on template metaprogramming. At that point, we realized that template metaprogramming can be not the most efficient or not the most powerful tool for reflection. So problem with that, I don't know if you're familiar, that template metaprogramming may create overhead in compile time, right? So we could have a very long compile time if we try to reflect and use that. And that sort of was the hint for why we don't want to go that direction. So then came a few other directions, different proposals. So basically this goes toward the line of syntax. So now, you know, the static reflection proposals and others have started to propose a language syntax instead of the template metaprogramming mechanism to be able to query our program. And in that point also came up the idea of meta objects. So again, let's say I have a program, I have a struct, I want to keep information on this struct, right? And what would be the most reasonable way to keep information on something in C++? Let's say I have a student. Someone would, you can just shout, what would you do if you want to keep the information on the student? Yes, you have some struct and you have members and you keep the information. That's exactly that. Meta object is basically a struct keeping information on our parts of our program, right? On the types of our program, on functions. So that's exactly that. In that point, you can see that Bjarne have joined the party by a paper. Bjarne, by the way, Starstrup is the inventor of C++. If any of you haven't heard the name, he was here last year, which was very exciting. And again, observation papers that try to basically define what do we need from this feature. And reflection TS followed. TS is a technical specification, was published by David Senkel. He also did some very, very thorough work on defining what can reflection be. And basically the syntax that we're gonna see today is loosely based on things that were introduced in this TS. Another concept that came at that point is value-based versus type-based, and also typeful versus monotype. So I'm not going to go into that in details, but let's say I want to build some representation of my program. So I could have types, I could have expressions, right? People here have studied compiler courses in university. How many of you studied compiler course or? Oh, wow, okay, that's very significant amount. All right, so I'm sure you've heard about parsers, and then you parse the program and you put it in some representation. Now, you could parse, for example, to some kind of a hierarchy, right? You could parse to inheritance hierarchy. Say, I have some general type, and then I have a specific type, int type, etc. So that would be a possible representation, would be into some hierarchy of types. But as it turns out, the compiler implementers, which are part of our committee as well and are active and give their input, and again, this is a very, very widely spread, supported proposal, So it turns out that this would be too heavy for the compiler to hold. So if you start building a full hierarchy struct of your types with inheritance or with some other method that is equivalent, sorry, you will end up with something that is very heavy for the compiler. Therefore, we settled for something that is monotype. So again, a single type, meta object type, that holds the information for any parts of your program and no hierarchy. All right, I think that summarizes that. So as you can see, with the amount of proposals as well, the closer we got to today, the more traction this proposal pulled, and we got different discussions on syntax of static reflection. By the way, until this day, last week the syntax was modified, and you're going to see the new syntax on those slides today. Comparing value and value-based and type-based, again, to address the performance gain that I've talked about. And of course, in 2023, October, approximately a year ago, we got the current proposal that is basically describing what the feature that is gonna be allegedly or hopefully will get to C++ 26 standard. So P2996 by Barry, Wyatt, Peter, Andrew, Faisal, and David. This is the proposal that we're going to talk about in today's talk. And thank you for them, by the way, for picking up this glove, because picking up this thing, because I think that the community wanted this feature for a long time, and it's not a trivial one to propose. So following that proposal, there were also different kind of papers talking about the usability. So things like Python binding that I'm sure, how many of you have ever heard or ever did in your company Python binding or other kinds of binding in between languages? All right, cool. There's also some, you could do it in C# and other things as well. And those proposals are there to basically give us some more information on the usability and how this should behave. But as I said, we're focusing on our proposal. And we're now 1.16 years later. So during the last committee meeting, we also talked about time points and extending time points to reflect frictions. So that would be an example of such. But we run 0.16 years later, and this proposal is in a pretty advanced stage, and as I said, forwarded to the wording groups. So this is what we're going to see today. So again, very likely to get to 26. So what do I mean by reflection? I've talked in high level before, but I want to show you a code example so that you can actually kind of get the sense of what does it mean. So let's say I have a library type here, and I inherit from base 1, base 2. And on my main, I can basically take this lib type. So as you can see, the double caret operator, in line 7. This is basically taking the lib type, and reflecting on it. So basically what we're doing right now is moving this information from our program to the reflection space, right? So people understand, like when I say reflection space or program space, it sort of makes you confuse you, or do you want me to explain more, or it's a metaphor, so yeah, cool. But the idea is that I have two separate domains on which I operate. I have the program, and I have reflection of the program, and that would be everything, all the information I hold on the program. So by using double caret, I move the information to the reflection space, let's say. In a sense, basically, I keep information on my program. And now in refexpr, I keep information on my lib type. Then, if I use bases of, which is a library function, right? Reflection, it's from the reflection namespace, as I said, stud meta. And this library function can query the object that I moved to reflection and basically get the information of, for example, bases of. So what I'm going to get in res, according to the latest proposal, is a vector of meta info objects holding two objects. One is base 1 and one is base 2, right? Same type, but different values. Cool. So we're all on the same page, right? This is what reflection is doing. Pretty cool, I think. By the way, most of the code in the presentation works. They're QR codes. This one specifically is just a slide code. All right, so I've already mentioned reflection operator. So we have double caret, and that's what we're doing to basically lift things to the meta space. And then we have splicers. Splicers are a way to take things back to the program space. And I'm going to explain more about these things in follow-up slides. We have the stud meta info object, and then we have a bunch of meta functions. And you can see from the amount of functions that this is really resembles what we have in standard library type traits, right? So I hope you've seen this list before. I hope some of those look familiar. Like, for example, I think template of, is private, is public, those things, you could find some kind of equivalent or, morally equivalent things in type trait library. And this is not by accident. Basically, what we did with the latest reflection proposal, and this was also discussed in details, like whether or not we need this, we also sort of duplicated, in a sense, the type traits that we have in the standard library because we're actually getting better performance, better information, more efficient way to query. Sorry, so I hope that helps. All right, let's move on. Okay, the first thing you need to know about reflection, and this is really this is really very recent news. So I've mentioned the lift operator, 2 carets, used to be a single caret. We had some clash with Objective-C and other languages, and we were, it was a large debate. So first thing you need to know is basically we now have double carets, also being referred to by the evolution chair as Unibrow. So you may be, this is not an official name, of course. You may see this name running in, as a slang addressing this operator. And now basically the competition is between different code styles, texting styles. Which one of them can make the distance between the 2 carets the smallest? So turn into a unibrow. But my slides were updated accordingly. So this is the syntax that you're going to see from now on. So I said before, we're lifting things into the reflection namespace, right? So here's an example. For example, I have an int, okay? Int is a type in C++, and I want to reflect on the int. So I use the double caret, and I get the information on the int. So again, what would be re-exper? For those of you who've listened and feel comfortable in answering, you can just shout. You don't need to. Yes. Wow. All right, good. So we are all on the same page here. Perfect. But this would actually not work. Anyone wants to try to guess why this would not work? And I gave you some hints in previously. True. So problem here is that I'm talking about things that happen in compile time with the compiler, and compiler cannot assume anything about things unless you mark them as const exper. So this is one, I'd say, something to take under consideration whenever you're using reflection in your code bases. So I've talked about taking things into the meta namespace, and now I'm taking them back into our program. So what does it mean to take them back into our program? Basically what I want to do is take the meta info object, right, as all of these groups have, have correctly said, and use this in order to declare new types in my program, right? I wanna reconstruct an int from the meta object that represents an int. And the way for me to do that is by using the slicer's syntax. So the second line you see here is basically taking my meta object and sending it back to what I'll call C++ domain, to the program. Now I can use this as a type and I can create an int. Clearly, you're not going to do this for something that you're already familiar with, that you can see line before that this is an int. An example of what you're going to do with this would be to query, like, for example, the members of a class, or to query the type of object coming from a vector or something like that, that you can't actually, or you possibly been defined in a different code, in a different place in your code, and then you can create the same object. So again, this is slides code. All right, I think we basically talked about that. So let's small recap. What is re-exper? What is that? That's true. Stud meta info object representing an int. And what would be type name splicer and then re-exper? It's true. Cool. All right, so you know basically you have all the basics, you know, reflection, and this is not a trivial syntax, so kudos to you for already capturing that in less than 20 minutes. It's pretty exciting. All right. So we talked about the reflection operator, we talked about splicers, sending that back to the program, and then, as I said, stud meta info. But we have a bunch of meta functions. We're not going to go over all of them in this talk because that would take us forever. But I do want to talk about a few things here that came up before. So first of all, you said you took a compiler course. So anyone recognize what is this piece of code or information? Yes? It's true. Anyone recognize on which compiler? Yeah, it's Clang. I mean, there's like 50%, I guess. So, well, if one of you would have say GCC, I'll just use the ones that used that said Clang. But yeah, this is an AST for Clang. So this is the abstract syntax tree. So after we parse our program, we basically keep the information on our program in some structure compiler holds about our program. And this is what the front end is gathering, then sending that to the back end to lower this to binary code, right? So you can see here some things that I've mentioned, like for example, you can see this piece of code on the right. By the way, this is from a different talk that I gave about abstraction layers that I welcome you all to also look. It's on a different topic, but related of static analysis. But here you can see the int that you see on the right, and you can also see you have the type, you have the value of the int, sorry, and you also have, if you can see the name, right? So I'll let that sink in for a second while I drink some water. Right, so our compiler already have all the information held, and now the question is only which part of those things we keep, right? Because you can't keep everything, right? That would be too heavy, too much information, and the program would be too slow. And then the question is which parts, how do we expose that to our user to be used? So again, settled for meta info. And this stud meta info can represent different things in your program. So it can represent types and aliases, it can represent functions or member functions or variables or non-static data member or static data members. So we have functions for all of those things. We have functions to query, for example, if you get back a vector of meta objects after you've reflected on a class, we have ways to query what is this thing. Is it a non-static data member? Is it a template, etc.? Yes, and okay, let's keep that because we're a bit short in time. And I've already expressed before that it's important to keep in mind those things needs to be constant or constant expert, because otherwise, I mean, it could be as a follow-up extension, but for the current proposal, the things we can reflect on are constant value and constant expressions. So that we already talked about. So here's another example of using this meta info. And now I have a question for you. We have class R. Everyone saw this class? Cool. That slides looks good. And I reflect on this R, right? So I lift it. I have a stud meta object to represent it. And now I'm calling the library function stud meta is complete type. So is this R a complete type at that point, at line 7? So what am I going to get? Oh, actually 0, but yes. No, I'm kidding. False, yes. All right. I then add a member to this class. I now have int R. Is this class now complete? Cool. So what's going to happen in line 15? Yes. So in line 17, I take res1. You know, res1 was taken in line 6, right? And I query res1. What am I going to get from is complete type on res1? Okay, how many of you think it's going to be true? Okay, raise your hands up so that I can see. Cool. How many of you think it's going to be false? All right, that's very interesting. Yeah. And what did you, Haskell? You said it's just. Yeah. Yeah, we definitely need more undefined behavior in C++. We don't have enough of it. Yeah. So there was a comment here by Haskell. Correct one. This is confusing. This is right. So I'll give you the answer. The answer is actually true. Why is this true? Anyone wants to guess or have some ideas? Yeah, go ahead. To the AST-like thing. Right, exactly. So this is what happens here. Res1 is not a snapshot of the state of the program at that point. It's basically like a reference to this representation, the AST. So even though you took res1 before the type was complete, you'll still get this result. So I would argue that it's a bit confusing, but this as a result of things that have been discussed. And also, I will say that this is requirements or a result of the implementation limitations that we have coming from compiler implementers. Yes, Uriel. Yes. Yes, it's well defined. Basically, the way to address this is that what we have is stateful reflection and not stateless. What does it mean, stateful? It means that whenever when I query things in different places in the program, the results coming from the stud meta functions can change. Cool. So we got this, this little bump in the road covered. And now we're going to go to talk about each of those meta functions. Not really. I said that before, that if you listen to me, that would be too long. All right, so meta functions. So we already saw an example of meta function, right? There was is complete type, pretty straightforward. Usability is pretty easy. We have a bunch of them. We can query the name of something, then print it. We can query like whether it's private or public, the access modifiers. We can query a bunch of things. The returns that we're going to get from meta functions are going to be things like string view, if that's like a name. We may get the stud meta info object that I've mentioned before. We may get a vector of such, Boolean, as we saw, etc. All right. So I think you now, by that point, you know what to expect from the reflection proposal. I would say you basically have some very good basic you now have the basics for being familiar with this proposal when it comes out. But I want to talk about other things that are not actually in this proposal. So I've mentioned type traits. So we have type traits from two kinds in the standard library, right? We have type traits that basically query, like isConst, right? And we have type traits that can modify things, like remove ref, for example, right? So we don't have in the current proposal things that basically modify. We have things that query. But I think that from my perspective as library evolution chair and person that cares about the standard library or focused on the standard library, I would expect a following proposals, maybe even from this room, for traits that use reflection and use some compiler magic possibly to modify the types that we get from stud.info. Okay, so that reason we haven't got this in the first proposal is that it's complex. You now modify what we talked about, the AST, the representation of the compiler. Still, I think that could be a very cool follow-up, and I would be happy to hear people here talking about that. So I'm not going to go into the examples that I have here on the slide. You can scan the QR code because we are a bit, this talk was also presented in an hour and a half. I do want to talk about function param names just to highlight one more point that can be maybe challenging again in reflections. For example, what happens if I have a function declaration with some param names, int A and int B? Okay, seems to be, yeah, no, it's fine, that's fine. Technical check, yeah. I thought you wanted to look at the slides and try to guess the answers, or because you can't see the answers, that would be cheating. So let's say I have a function declaration with int A and int B, and say that up down the line I have a different function declaration. There I called int I and int J, and this is the same function, right? What would I get back when I query the names of the params? Anyone have guess? You can. There's not in the P2996, but there's a follow-up proposal that proposes the ability to do that. Okay, implementation defined. That would be, so think about a use case of a logger. Let's say I want to write a logger for my program, and I now change the compiler that I use to compile my program. So implementation defined would mean that I get different results from the logger, and that could be a choice, but it could be a bit problematic if I'm in production. What?
There can be only one definition, but several declarations.
Yeah, I said.
With respect to the names. So I would hope, I don't know, but I would hope that it's the names that come from the definition.
All right, so that's another option, just to take this from the definition. Even though you can reflect before you saw the definition, like you can reflect on an incomplete type. Yes? I just gave you an example, a logger, for example. If I want to log, if I want to look at my program and log, yeah. All right, so this is actually a trick question. We have discussed this paper, but it's still open question. so yeah, you brought up a few options. I guess I can say that we're leaning towards just not being able to reflect if there's no consistency. But this is not, again, I want to put the disclaimer that this is not a final decision, because this is exactly the type of things that we're still discussing in Library Evolution. All right, how many people think that you should not be able to reflect if there's different names? With raise of hands. How many people want to see the latest definition/declaration, the names from the latest? Cool. How many people want this to be implementation defined? So if you modify the compiler, you may get different answers. All right. This is fun, isn't it? Yes. Huh? Just make it what? You want this to return a vector of meta info with all the names for each param. Yeah, that's an option. We'll see, maybe. What? Right. Also, you can also have declaration with no name. So we basically made that ill-formed. So that cannot actually, because you don't get back a meta info object with no name. You just don't get. It's ill-formed. A compiler will fail. That we actually decided. All right. Cool. Okay. So now you get the sense of how it feels to talk about those things, how complex they are, and what choosing the right path is a challenge. So I want to talk about one last thing in the approximately 10 minutes I have before some questions, for time for questions. So we can basically talk about reflection as another tool in the language. That means that we can get libraries based on reflection, right? But what happens if I pick, like, if for example, let's say, we go with the rule of saying that this is ill-formed if you get different names for func params. And then someone writes a logger library based on that. And my logger library works perfectly well on my code base because in my code base, the names are consistent. But now I take this logger library to a different code base and I try to use it and I get, my compiler fails. I get ill-formed, right? Because not all the code bases are consistent in this term. So we need to keep that in mind. When we use reflection as a tool, there's a lot of things to keep in mind in terms of what can you basically expect and not expect. So I don't want to go into the question of ABI. Maybe some of you have heard about ABI and limitations of ABI in the past, that those things have been discussed as well in standards committee, whether or not you can break the representation of a type. But in reflection, for the very least, and this is again, if you need to take one thing from this talk, and I'd love you to take this point, we don't guarantee consistency between standard versions, even within the same version. Because we already talked about some use cases on which the same function can return different values, right? So we can make those guarantees. This is important to remember. All right. So we talked about func param names. You've brought up all of those things, so that's fine. Also, there's an option to mark by attributes. That's also an option that we've considered. Basically, you could mark the declaration that you want the names to be the most, like, use the names on this declaration. That's another thing that came up. Right. So I talked about that as well. Sorry for jumping. All right. So another thing I want to mention, I've talked before about customization points. So anyone knows what customization points here or heard this term before? All right. Customization points, very broadly speaking, is the way you integrate your user code with your library code. So let's say I have some library and I want to ask the user, for example, user provide me some type, and I want to ask, how do I swap those types provided by the user? That would be an example of customization point, right? So reflection by itself, by being able to reflect on the program, gives us more ways to provide customization points, right? Because now I can observe the type from the user, right? And I can basically, I don't know, I can basically say, give me some swap member function, and I'm going to use it in my algorithm. So this is opening the space for us to be able to modify our programs and in a way to interact with library code. But this is also, in a way, it's also a dangerous tool, right? Because reflection is actually enabling you to do a lot more than what you could do so far. And in a sense, you can modify the program indefinitely, or you can get something out that was really, really different than what you got in. So we need to use this tool with a responsibility, and we need to note the fact that we have very strong tool in our toolbox now. So yeah. All right, so I'm not going to go into all of the customization points because that would be long. But this is an example of how to use reflection as customization point. All right. Sorry about that. So again, I want to go back to the question, what can you guarantee in reflection libraries, right? So I gave you an example with the logger. And can I guarantee that my logger would work on all the code bases? If the code bases, if we decide that, you know, different function declarations have different names, then we get something ill-formed. That means that I cannot guarantee that, right? So that's actually been discussed already. There's other things as well, like other open questions that we can discuss in this domain. And the thing that I think is most interesting, and if this is the second thing you're going to take from my talk, then I'd hope for you to take it, is that we need your input. Okay, the kind of examples that I brought up here are only part of the examples that we stumble across. And if you, for example, have been working with some reflection framework, if you've been needed to reflect on your code, probably you've done this with template metaprogramming, but you have this usage experience, I would be very happy to get an email from you so that you can tell me what you think is the best defaults, what do you think are the best ways moving forward, what do you think is important to get in this toolbox. Because this is exactly what we need. We need your input. Last thing I want to talk about is the pipeline integration. So I've mentioned that reflection is gonna basically modify the way we use code, modify our CIs. So I already talked about, let's say I have a regular library, the logger library. And I'm basically linking with some application code, and I get this object, and I get the linker connects the two objects. Everything works fine, right? Now with reflection, basically I have a way to control, by the way, all kind of implementation details by version or by macros. I can turn on and off parts of the implementation using macros by querying. So what happened with reflection? Reflection, I have my logger library and I have my application code, but the point on which I find out that the logger library doesn't work with my application code is not in the linker, right? Where is it? Yes, exactly. It's in the compiler, right? So this behaves differently than what we've been introduced to before. This means they have different implications. If, for example, there are some products that basically use dynamically linked libraries, then if you used to find out that you have a problem or different versions in the runtime, this is a different thing, right? So those kind of things that you need to keep in mind when you work with reflection, and these sometimes been overlooked. Our CI can be modified by this. Maybe our toolings also need to be modified by this new tool and addressing it. And that's, by the way, I talked with JetBrains representative, Anastasia. She was here, I think, she was here, I think, one of the years in core CPP. And this is very significant for them, right? This is a new tool, but it have impact on the CI. So before I finish, I want to summarize. When we talk about reflection as a tool, we need to also think about the implication for our code bases. We need to think about what does it mean to have reflection libraries. We need to think about this very powerful tool being able to modify our code bases in a more extended way than we could before. And we also need to keep in mind that there's a contract between us and between the developers or the application code. For example, if you run a reflection-based library, there's a contract between us and the future application code that may come up after our library has been written, and we need to keep those unless we want to get broken code bases. And the last thing is that another interesting point on this, reflection is kind of a language within a language, right? You have C++, now you have reflection. Let's say I run a function, a reflection function on my code base, and it fails. What should be the behavior? Like, we used to have compilation errors where our C++ code is ill-formed, right? What happens if I run a meta function and I get an empty result? So should it not compile? Should I get a compiler error signaling, like, pointing me to the place on which the problem have occurred? Sorry. Sorry. And basically pointing me to the point on which the problem have occurred. Do I get, do I get an exception? So now we have compile time exceptions. I don't know if you heard about this, but this is also something that came up pretty recently, and we can now mark exceptions at compile time and sort of get this internal mechanism of compiler run with those exceptions. And do we get an exception of such failure of reflection code? How deep do we go into giving the users the tools needed to use this language on top of language, to basically help them program with reflection correctly? These are all very interesting questions. So I will give you a brief answer, is that for now, everything that fails in reflection is more or less ill-formed. It will be a compiler error. But you can still think about, like, is the compiler telling me in which line is it, or what should I do? Like, sometimes with template metaprogramming, we get really, really bad compilation errors, right? So maybe we want to do better with this tool. And how much should the details? Did the compiler just tell me, I didn't manage to run this function, or does it actually give me hints on how to fix it? So this is very interesting open questions that we have. Right, so this is the plan. This is the plan that Herb Sutter is making. Herb Sutter is the convener of Workgroup 21, which is the standards committee group in charge of C++. And you can see that reflection was basically, as I said, it was mentioned in 2006. For Herb, at least the more mature, the more versions of reflection as we know them today have started being discussed in 2018. But you can see that we're basically on the edge of getting reflection, and I think I am very optimistic. I think we actually will get it for 26 because it have a lot of support. But keep in mind how long this kind of feature has been discussed and needed. So just to give you a bit of a hint on how the timeline works. Thank you, everyone. And yes, and I'm going to stop for questions. I just want to thank the core CPP user group that I gave first version of this talk. The authors of Reflection, Matush, David, and David is not the author of the newest proposal, but is the author of TS. Corentin gave feedback, people that gave feedback to my talk. And yeah, and thank you for being here, and thank you for being passionate about C++. All right, so I have 5 minutes for questions. I was trying to get a bit more, but let's do it quickly. So first of all, how many of you are excited about reflection? Good, I did my work. All right, questions. I saw something, yes. Right. That sounds like it's really compatible with how it's. So what's your name? Avram is asking. So I don't know if you heard, Herb Sutter, as I said, the convener, also have a front end, a different front end called CPP2. Basically trying to, like, he defines it as an experimental project defining features so that you can experiment with, and then later to be proposed for C++ language. So it's a different front end, still running C++ or C++ equivalent. And Abraham is asking, Herb was leaning toward the direction of not the order of declarations shouldn't matter. So I would say two things. First of all, the things in CPP2, they still need to go through some process. So CPP2 have more freedom, right? It's that C++ is a language exists for 40 years. And it means that we can't necessarily apply all modifications we hope for, and even putting aside the technical discussion. So the fact that it's in CPP2 not necessarily going to impact C++. On the other hand, I agree with you. This does add more landmines, and that's why I said you need to use this, with respect to the complexity of the tool. Yeah. One more question, because I'm actually kind of... All right, thank you everyone, and feel free to reach out if you have more questions. And my email is on the screen. If you have use cases or requests, please feel free to reach out. This is exactly what we need. Thank you.